This is a recording that's intending to go along with Chapter 4, which is querying multiple databases, or multiple tables rather, not multiple databases. So yeah, this is all mostly about joins. And last time I did, before the last recording, I did like examples straight from the chapter, and this time I'm not going to. I went and went through them just to make sure there weren't any surprises or questionable parts. And the only thing I'll say is that the author does not always make it clear, super clear at least, when you're switching tables or databases, I mean. So remember the whole thing about like use AP, like so, and then you hit Control Enter, and then you're using that. And then every so often in the exercise from the chapter, he'll switch to using like the X schema, the X database, and so then you have to use X. And then you just have to remember that stuff. So if it's saying, yeah, like, table not found in there, double check and make sure what database he's actually using, and then you might have to switch here using this. I think that's the only gotchas that I really found from the chapter. Okay, so what am I going to do then? Well, to make things easier, I'm creating just about the simplest table that I can imagine. Simplest database, rather. It's going to have two tables in it, and each one is going to just have one column. That's it. They're not even going to have any keys, no primary keys, no foreign keys, nothing like that. And one of them is going to be a table that has a few of my favorite foods, and then another one is going to be a table that has a few of my significant others' favorite foods. And instead of building it before the recording, since you were expressing interest in kind of jumping ahead, I'm just going to go ahead and show you where we're headed a little bit later on, I believe in Chapter 5. But we're going to actually go ahead and create a database and then create the tables and so on. So I'll go ahead and do this here in this query box. This is going to be create database. Even though these are called schemas over here, actually I've never tried create schema. It might work. I don't know. Never done it before. Maybe I'll try it after the recording, but I won't try it right now. So I'm going to create a database that's called Fave Foods. Notice the underscore, just like the author is doing. This is just kind of conventional naming stuff in SQL. And I created the database down here. As long as I get the green checkbox, should be good to go. And then I'm going to use Fave Foods. Control Enter. Green checkbox. That's good. And by the way, if it's not showing up over here, and this navigator is not really good at refreshing itself, then we should have this little guy here. And then there's the new Fave Foods. So doesn't have any tables in it yet. I'll go ahead and make some tables here. Same syntax as create database. It's going to be create table. And this one is going to be my Fave Foods. And I want to go ahead and tell it what column I'm going to have in there and what data type. Now these get a lot more complex than just this. Very often there's stuff that goes after the closing the closing parenthesis here, as well as, for instance, like what kind of what database you're using, like DB, or using UTF-8 for your default character set, stuff like that. But I'll just go ahead and keep it simple here. It's only going to have the one column, and it's going to be called food, and the data type is going to be variable characters, and I'm going to allow up to 255, probably more than we need, but still. So create table my fave foods. I'm going to go ahead and just type everything out. Of course, if you're doing something similar, you can copy and paste. I find that for demonstration purposes, it's better if I type everything. And also, if me personally, I get into the thing where if like copying this and all I have to do is change like one little thing about it, I tend to make errors. I tend to do typos. So I'll just go ahead and type it over from scratch. I mean, I can make typos this way too, but it seems like I make a lot of typos the other way. So if one of the tables is going to be my fave foods, the other one is going to be the fave foods of my significant others, which is going to be so fave foods, SO fave foods, something like that. And otherwise, it's going to look exactly the same. It also will have a single column called food with varchar 255. like so, and hit Control Enter. And I'm not seeing the create table down here. Let me go ahead and refresh over. I'm going to grab tables and then right click and go down to refresh all so I can check, and it looks like this one didn't take, so I'm going to do Control Enter up here again and refresh all, and then okay, so the Control Enter just didn't take, or I didn't type it correctly or whatever. Okay, so now I've got both of those, and I'm going to be putting in some values for these guys. So let's see here. I'm going to do insert into, and we'll do my fave foods first. Tell it what columns we want to update. In this case, it's only one, but we still have to put it in there. We're updating food column. And then values, so I can put in multiple values here. So I'm going to put in several things here. So my favorite foods, some of them are enchiladas. And pizza, of course. And French fries, of course. And ice cream. I don't know about you, that looks like a pretty good list to me. Enchiladas, pizza, French fries, and ice cream. That would keep me happy for a while. Control Enter. And I'm seeing green down below, so I'll do the same thing for my significant other. This one will be into So Fave Foods. Also into the food column. And the values will be a little bit different here. Some overlap, so I'll do pizza, sure. It's kind of a gimme, right? Pasta, ice cream, and well, she likes desserts, so I'll put in cake. Okay, so Control Enter, and once again seeing the green. We'll check these in just a second, but just notice for now that there are some places where these have some things in common. I did this, deliberately. So there's pizza in both of them, there's ice cream in both of them, but then enchiladas and French fries do not match pasta and cake down here. So just make a note of that. Let's go ahead and do a select all on both of them just to check them out. Select all from my fave foods. And I'm getting the result table down here, and there they are. There's my 4. And I'll do the same thing for the other table. I'll do select all from So Fave Foods. And there we get the pizza, pasta, ice cream, and cake. Okay, cool. So, good to go. Let me see if I can move this down a little bit, give myself a little bit more room in the actual text area up here. There, that should work nicely. Okay. Now, we're going to be doing joins, and there are 2 broad categories of joins in SQL languages. There are inner joins and there are outer joins. An inner join is what you do most of the time. An inner join is where you're grabbing data from 2 different tables. In this case, it's hardly any data. Usually it's more complex than what we'll be doing here. But you're grabbing data from 2 tables, and what you're doing is you're matching entries across columns in the different tables. So what it'll do is it will only return entries that match each other from one table to another. So we've already seen, right, we've got pizza in common between the 2 columns in the 2 tables, and we've got ice cream in common between the columns in the 2 tables. So those are the ones that I would expect to return on an inner join, and the other ones would not be returned at all. So if you've ever seen a picture of a Venn diagram, V-E-N-N diagram, it's like 2 broad circles and they overlap a little bit, and where they overlap is the data set that you're getting. And that's what an inner join does. It returns a Venn diagram, basically. Outer joins, there's 3 different kinds of them in SQL. A full outer join would do pretty much the opposite of what an inner join does. If an inner join only grabs matching entries, a full outer join grabs all entries from the specified columns in both tables. It does not filter them at all. It just brings everything in. I personally don't see how that would be useful. And as it turns out in MySQL, it doesn't even exist. I mean, there is something called a full outer join, but it's not available in MySQL. Other SQL languages, I believe, or flavors do have it, but MySQL does not, so you don't have to worry about that one. What we've got for outer joins, we've got a left outer join and a right outer join. So we'll get into those, but let's go ahead and go into, let's do inner join first here, because this is the one that you use almost all the time. I'm sure I've used outer joins before, but I could not come up with an example of one in my head. Like I couldn't remember having done it. It must have been a long, long time ago. Almost always you're using inner joins. So let's go ahead and check this out. So again, I'm going to type it all out explicitly, and we're going to do the explicit syntax at first. So it'll be like the fullest version of this. So these will all be select clauses. So I will do select all and from, and I want to specify both tables now. So I will start with my fave foods, and we'll do an inner join. Notice again, all the clause names and keywords and so on are in all caps. We're joining this to the so fave foods table, and then we need to tell it what on. Now, even though right now it may be obvious, like there's only one column in each table, so we must be using that one to match it up. But MySQL does not make any assumptions about that. And of course, normally that's understandable because it's very rare that you will have two different tables with only one column in they're comparing. Sometimes you have a table with only one column, but even that's rare. Usually at least have a primary key or something. Okay, so select all from my fave foods, inner join so fave foods on, and this is going to tell it what columns to do. Now, if you just look at the syntax, you might be tempted to do something like this on food equals food, because that's the name of the column in both of those. But if I do a control enter now, I'm going to get an error message. And what it is it's ambiguous. If you can't read all this on your column, oh, it's not allowing me to, oh, there we go. So if you select it down here and do copy response and go back up here and just paste it, then you can read it here. But I can tell you right now the ambiguity is that, like, yeah, I don't know which column is which here. And it doesn't seem like it would matter, but it does. So I have to specify my fave foods dot food. And I'm comparing that to so fave foods dot food. Okay, and now if I do control enter, now it gives me the result set here. So again, this is the inner join, so this is what it does. It's only grabbing the entries that match each other. So on the left column, on the left table, enchiladas and what was the other one? French fries doesn't get matched here, so it doesn't show up. On this other table, there was cake and pasta, and those didn't match anything on the other one, so only the places where they match. This is the most useful kind of select query. Again, I'm going to say like 95% of the time this is what you're doing. You're just matching up columns. Now, normally what you're doing is you're matching up the primary key in one table to the foreign key in another table. That's the usual thing to do. But in this case, again, I'm just keeping it as blinding simple as possible. We don't even have those guys. So let's go ahead, and I'm going to simplify this query a little bit because there's some things that you can shorten and maybe even leave out. So I'll start it the same way. I'll do select all, and this one's going to do exactly the same thing, but it's going to be a bit shorter. Now, first of all, I'm really going to get tired of typing in my fave foods and so fave foods all the time with all those underscores and everything, so I'm going to use an alias. So right after putting my fave foods, I'm going to put a space and then a shorter, usually the initials, like MFF. And now, whenever I need to type in my fave foods, I can just type in MFF. That's an alias for the original column name. And then the inner join. And then I'll do the same thing for so fave foods, space, and then call this one SFF. And now see how much shorter the next line is going to be. I can just do MFF on MFF.food equals SSF.food. And oh, I like that better. That's definitely easier to type. And control return, I get the same result down here. So cool. I'm going to do one more. So that we can save more time still and typing. Select all from foods, put in the alias, and then here I'm just going to type in join instead of inner join. And then the rest of it's going to look the same. We'll talk about that in just a second. Foods, and then the alias ssf on mff.food equals ssf.food. Okay, so here's the deal. The word inner, the keyword inner, is optional. You can type inner join if you want to, if it helps you remember that this is what it is. But if you just type in the keyword join by itself, MySQL knows that this is an inner join. In order for it to be an outer join, you have to have other keywords in there. So this is sufficient in itself. And then this is the shortest version of this that will do the same thing. And ssf.foof. Oops. That's what happens when I try to type too quickly. In fact, I did it twice there. I wasn't even copying and pasting either. There we go. Pizza, pizza, ice cream, ice cream. Okay, cool. So there is an alternative syntax to this as well that sometimes it can seem more convenient and efficient, but it really doesn't save many characters. But you should know that it exists because especially in older code bases, you're going to see it sometimes. So whoops, I don't need to save that. Okay, and so this is the alternative syntax, and once upon a time, this was the only way to do it, I believe, if I'm recalling correctly. So select all from, and then instead of using the keyword join, just use a comma. My fave foods. And let's see, I'm doing the implicit syntax, so yeah, just the comma. And then, actually, you know what? Let's go ahead and do the aliases here too. So mff, comma, so fave foods, sff, excuse me. And then instead of using on, use where. So just like a regular where keyword where you're specifying like conditions for which entries are going to be returned, this does exactly the same thing, except it's pulling from two tables at the same time. So where mff.food equals ssf.food. And control enter, and again, it does exactly the same thing. So I don't know which one of these you prefer. I've read things that say, yeah, you should really be using this one now, but I have yet to read any good explanation for why, like why this would be not recommended if it does exactly the same thing. I don't know. I'll keep looking. I keep trying to do that. I'll keep looking and see if there's an actual suitable explanation for why this one is not recommended anymore. Like I said, I think it used to be the only way that you could get this kind of join done. Okay, so let's see. I wanted to show a few ways of reducing this to a single column. So right now we're getting two columns. We're getting one from each table, and it's just duplicated information. And so we're repeating ourselves, and that's kind of, well, it's not the best way. We want to make it nice and readable, right? So the first way is just to do the simple select, the same kind of syntax that we're doing right here, except that instead of grabbing all, which is what it's doing, I'm just going to grab the food column, and the rest of it's going to be the same here. So I'll use the join syntax again. So my fave, sorry about the typing, alias, join, remember inner is implied, so you don't need to use it. So fave foods, alias, ssf, on food equals ssf.food. Now this is not going to work, again, because of ambiguity, right? I'm going to get that same ambiguity message here. I have to say which one it is. Do I want the food column from the first table, or do I want the food column from the second table? I'm going to generate another error here. So I'm asking it to go to my fave foods and grab the food column from that, and it's complaining about that too. It's saying unknown column, my fave foods.food. Saying I can't find it. What's going on? Well, what's happening is, remember these guys here, as soon as you declare an alias, you have to use it. Not only afterwards, but even before you declare it, you have to use MFF here instead of my fave foods, or else it won't work. So if I instead do MFF.food, so it's like it's hoisted, right? As soon as you grab this, it hoists up to the top of the select of the top of the query. And now it works. And you see that it gives me now just one column instead of two. So if that's what I want, then I can do it using the same kind of syntax that we've been using all along. on. And there's a couple of other ways to do it as well. And the textbook mentions both of these, so I'm going to do them also. And the first one is using the keyword using. So let's go ahead and try that. So if I do a select all from my fave foods, and I'm not going to bother with the aliases this time because this is going to be the last line that we have to do. We're not going to be using an on keyword down here in order to, so we won't have to use these again. So from my fave foods, join so fave foods, and then just say using. So this is kind of replacing the word on. And instead of saying like mff.food equals ssf.food, we just do food. Now the thing to remember, and the thing I often forget, is that this has to go in parentheses in order for it to work. So I do Control Enter now. See, this is enough just by itself just to return the one column. And I think it's nice to know this because this is considerably shorter than this guy up here. It can save you some finger fatigue and so on. If you do want, let's say you're using the keyword using, and you do want to get both columns, then you have to be more explicit about it. You have to actually say food and food. But notice I don't have to specify which is which. There's something about having this in parentheses using the keyword using. I know I keep saying using, but that you don't have to specify. It's like it's now smart enough to figure out, oh yeah, use food from one and then food from the other one. And as you can see, that'll go ahead and get me the two columns then. No errors, no problems. So that's kind of cool. The other way to specify or to remove the duplicated column from the result table is to use a natural join. And I think this is actually the shortest one of them all. If I do the select all from my fave foods, and once again, like as the above, with using, we're not going to need the aliases on this because this is going to be the last line we have to write. And it's just a natural join. So technically it's a different kind of join, but it produces the same kind of thing. It's still an inner join, but it just gets rid of the duplicate. Let's see, so fave foods. And then this is it. You can see this is the shortest one out of all of them so far. Control Enter, and again it gives us the single column here. And so that can be handy to have. Very often a natural join is not sufficient for what you need. If you've got some sophisticated conditions about what's matching up to what and so on. A natural join very often won't be sufficient, but for a very simple use case like this, it works just fine. Okay, so next up, let's do outer joins. So again, remember there's the three possible kinds of outer joins that I know of. There's a left outer join, right outer join, and full outer join. Full outer join does not exist in mysql. Don't need to worry about that one. So what do these outer joins do? Well, if an inner join only retrieves the matching items. So I'll go back up to this guy right here and do Control Enter. So I'm selecting all and I'm getting both of these, but these are only where these entries match each other and it's leaving everything else out. So an outer join, what it will do is it will return the matching entries that the inner join will do, and then it will also return the unmatching entries from just one of the tables or one of the columns. And where it does not match any entries in the other column, it will return null values. Now, the left outer join means that it will return extra unmatching values from the first. This is what it means. Like this is, in this example, this is the left table, and then this is the right table. That's all it means, left and right. So it'll return the matching entries from both of these, and then it will also return unmatching entries from the left one. This is the left outer join. And where they does not match, that will it will enter in null values for this. Let's go ahead and try it out because it doesn't really make sense until you see it. So let's see. It starts off the same way. Select all from my fave foods, and we'll do the alias again. And this time we'll do left outer join and so fave foods with the alias, and then on mff.food equals sff.food. No surprises there. Okay, so again, this is going to return the pizza, ice cream, and ice cream. It's also going to return enchiladas and French fries from this one. And where they don't match, it'll return null values over here on the right. So check it out. Control Enter. Here we go. So it's giving the full list from the left. That's what the outer part means. It's returning results from outside of the Venn diagram coincidence. And then on the right side, okay, pizza's matching pizza, ice cream's matching ice cream. Where it's not matching, it just inserts null values here. So that's what an outer join is. And I'm not going to do another one for this, but just so you know, the keyword, just like the keyword inner is not necessary for inner joins, the keyword outer is not necessary for outer joins. As long as you got the keyword left in there, it'll know that you're talking about a left outer join. So I hit Control Enter, does the same thing. Let's do a right join. So it's going to look exactly the same, except that it's going to have right join instead. So select all from my fave foods, MFF, and this time we'll do right join, foods SFF, and then on food equals SFF.food. Okay, so this time it'll return the full set from the right table, which is the one from SoFave Foods, and it'll return matching entries on the left table, but then null values where they do not match. So we'll get the full complement here of the pizza, pasta, ice cream, and cake, and then pizza and ice cream over here, and then null and null for the cake and pasta. So let's check it out. Here we go. So pizza, pasta, ice cream, and cake, matching values, and null values where they don't match. So that's a right join. Now right joins, I don't think it's really necessary to ever even do right joins, because you can get the same result by using left join and simply reversing the order of the tables that you put into the query, right? I mean, it'll reverse these two columns here, but that doesn't matter. Let's go ahead and do the same thing using the left. So I'll do the select. Come on now. Select all from, and here's where I do all the typos, but I'm going to reverse these guys. So put SoFave Foods and SSF on the left, and then go back to using the left join. And then this time my fave foods, MFF on the right, and then do the same thing. Now down here, it doesn't matter what order you put these in. Equals is equals, right? Unless you're doing some other kind of comparison operator, like a greater than or equal than or something like that, then it would matter, of course. But if it's just a simple equivalence that it's looking for, then we're good to go. So we've reversed these two and done left join instead of right join as we did up here. Same result, except the two columns would be reversed. And there we go. Now pizza, pasta, ice cream, and cake, and then the matching and null values over on the right. So that's what's recommended instead of doing a right join. So really with the joins, I mean, ignoring for a moment the inner join, or not the inner join, I'm sorry, the natural join and the using keyword, as well as one or two others like cross joins and so on that we haven't really talked about. There's really only two things that you have to remember. If you do join, then that means an inner join. And it's going to grab only matching sets. And if you do left join, then that's an outer join where it returns matching plus any unmatching items from the left-hand table. That's really, so that's it. That's what it boils down to. Those are the only two joins you really have to remember. The other ones are just kind of icing. There is one more thing that I'll throw in here, and I'd kind of forgotten about this one, but it's in the chapter, and I think it's kind of a cool thing. And it returns something kind of different from any of these. So these are all ones like, well, not all of them, but let's say go back to the inner join here, using this guy here. So this returns the pizza and ice cream. So this is what my significant other and I might decide how to decide what to have for dinner by querying our database, because of course we keep databases around for that sort of thing, right? Yeah, pizza and ice cream. That's stuff we both like, so we're going to have it for dinner. But you know, if we do that same query night after night, then I don't care how much you love pizza and ice cream, eventually it's going to get a little bit old. So let's say one night, instead of getting the specific query like this, what we want is we want to have a list of all the stuff that we both like. So a complete list, and get a result table for that. And oh, by the way, we want to have duplicates removed from that list to make it easier to read, right? So that we want the duplicate pizza removed and the duplicate ice cream to remove. That would just confuse the issue. So let's go ahead and do it. This is going to be a union. And it actually, instead of being a single query, it actually is like merging two different queries together. So, and by convention, you indent the queries themselves. So these are going to be very simple queries and just a union keyword in between, or actually it's an operator. So I'll do select all from, and then I'll do my fave foods, and then union, and then the other query, select all from so fave foods. And so again, what this will do is it'll grab all the entries from both of the columns and then just remove any duplicates. So in a way, instead of comparing columns to each other, it's saying, okay, what's common between the two columns, right? What matches across the columns? It's saying, okay, what matches between entries, and then remove duplicate entries from there. So let's check it out. Control Enter, and there is, bring this up a little bit. There's our full list of foods that both I and my significant other like, but it's taken that list of 8 entries and reduced it by removing duplicates, pizza, and ice cream. So we've got our list of 6 here, and so now we've got a list of things from which we can choose. Maybe tonight we'll have enchiladas and cake instead of pizza and ice cream like we always have. Okay, so that's basically it. Do still go through, I'll figure out exactly which exercises at the end of chapter 4 I recommend that I will ask you to do. And just watch out for when he changes databases in the middle of the chapter. If you actually read all the paragraphs describing the figures, then it makes sense because he says, oh yeah, we're going to be using this database now. But if all you're doing is looking at the figures and examples, you might not know that because it's not, as far as I saw, it's not explicitly contained within the figures themselves that, yeah, we're using the X database instead of the AP database. So just watch out for that. Okay, that's it.